Hi guys, in DC to DC converter we will have a fixed DC voltage source, and in the output we require a variable DC source. We have already studied AC to DC converter. This is also called phase control rectifier. Phase control rectifier, where we have a fixed AC source and in the output we desired controlled DC voltage. Controlled DC voltage. In case of DC to DC converter, in the input we will have a fixed DC source, DC input, and in the output we expect controlled DC voltage. Controlled DC output. Controlled DC output means you may have a DC output of some voltage, and later if you want to change the voltage of output, you may change it by controlling duty cycle. I will define duty cycle little later. Okay. If the magnitude of output voltage is greater than magnitude of input voltage, the output voltage V0 may be less than input voltage. In this case, this converter will be called buck converter, and this is also called a step down chopper. If output is greater than, output can be made greater than input voltage, so this type of DC to DC converter will be called boost converter, and it is also named as a step up chopper. So these two types of chopper you would have studied in your BTech course. Apart from these two choppers, these two converters, there is third converter in which output may or may not be greater than input voltage. Output may be greater than input voltage and output may be less than input voltage. In buck converter, the output voltage will always be less than input voltage. You can control the output voltage, but in each case output voltage will be less than input voltage. In boost converter, although by controlling duty cycle you can vary the magnitude of output voltage, but output voltage will always be greater than input voltage. In the third category of converter, this is buck boost converter. Buck boost converter. In this type of converter, the output may or may be greater than or less than the input voltage. So these two type of converter we normally study in our BTech course, but nowadays questions are being asked from buck boost converter also in GATE examination. So we will study this converter also. So first I will start with buck converter. This is circuit diagram for a step down chopper, where we have DC input voltage and across a parallel RC load, or let's say this is load resistance. Across load resistance the output is taken. This is a controlled switch. This is high frequency controlled switch. High frequency controlled switch. Control switch means I'm saying in simple language, when you will give gate signal, okay, this switch will conduct. When you will remove this gate signal, this will be switched off. In case of buck converter, the current has always the tendency to flow in this direction. So when you will give gate signal, the switch will be on. When you will remove gate signal, this will be off. And high frequency means its switching frequency will be high. Let's say it has a switching frequency of f. So in 1 second, f times this switch will be turned on and f times this switch will be turned off in 1 second only. Let's say f equal to 500 hertz. So in 1 second, 500 times this switch will be turned on and 500 times this switch will be turned off. Means in 1 second it will complete 500 cycle of turning on and turning off in 1 second. So what will be the duration of one cycle? 500 cycle is completed in 1 second, so one cycle will be completed in 1 by 500 second. This is 2 millisecond. So in 2 millisecond, one cycle is completed. One cycle means in one cycle only it has to be turned on and turned off. It means in 2 millisecond only it will be turned on and it will be turned off. If we draw the switching cycle, let's say this is 2 millisecond, and in 2 milliseconds suppose it is turned on for 1.2 millisecond and then it is turned off. Okay, one cycle is completed and in the next cycle same thing will be repeated. Means again it will be turned on for 1.2 millisecond and turned off for the remaining time of the cycle. So here I have completed 2 cycles. Similarly the third cycle will start, and saying switching frequency is 500 hertz, it means in 1 second it will complete 500 such cycles. It is on for 1.2 milliseconds, so we will say turn on time is 1.2 millisecond and turn off time is 0.8 millisecond. The total time turn on plus turn off is switching duration of switching cycle or switching time period. Switching time period is 2 milliseconds. The ratio turn on time to switching time period, this will be called duty cycle. So what will be duty cycle here? 1.2 divided by 2. This is 0.6. Okay. When I will derive input-output relationship in this circuit, we will be oftenly required to represent T on in terms of duty cycle. Okay. So T on will be duty cycle into T. Similarly, what will be T off? T off is, this is the duration T off. T off will be total time minus T on. Total time minus T on. Total time is T and T on is dt. This is 1 minus d into T, and I will represent 1 minus d as d dash. This is d dash into T. So T on is dt, T off is d dash into T. So I hope you understood about this part of the circuit. I will derive the input-output relationship formally, but before doing that, let us analyze it without writing any formula or any expression. What will happen if you will give a gate signal? When you will give a gate signal, this will be connected. Okay. When this is short, what will be voltage across this diode? This voltage will be plus minus V input, since this is short. So if you apply KVL in this circuit, this diode will be reverse bias. So as soon as you will connect this switch, as soon as you will turn on this switch, this diode will be reverse bias and this switch will be disconnected. Okay. Since this is a buck converter, so this is expected that output voltage will be less than input voltage. Okay. So let us, when it is connected, it supplies some current I. So some part of this I will go to capacitor and this part will flow through load resistance. If a current will enter in the positive terminal of capacitor, the capacitor voltage will rise. So it seems that from the circuit that when you will connect this switch, capacitor voltage will rise. What will happen if we disconnect this switch? For the duration of T off, what will happen? When you will disconnect, before disconnecting this switch, the inductor would have gained some current. It will have some current, and this current cannot be suddenly made to zero. So this conductor will continue flowing a current IL. And now what will be the path of this current? Since this path is disconnected, okay, so now the path of the inductor current will be through load resistance and through capacitor, and in this case the inductor current has to flow from this diode. So in this case diode will be short. In this case diode will be short, and now current will flow through this part. If you will analyze voltage across inductor, this is the reference. If you will analyze voltage across inductor, you will find that in this case voltage across inductor will be negative, and if this voltage is negative, L di by dt will be negative, hence the inductor current will decrease. Again, when you will connect this switch, okay, I will show you later, inductor voltage will be positive, so di by dt will be positive and inductor current will rise. What is the role of this capacitor? Why a large capacitor? Here we connect a large capacitor. Okay, what is the role of this large capacitor? Even if you don't connect a capacitor here, you will get output voltage. So to study the role of this capacitor, let us solve a numerical, and there we will observe the effect of this capacitor to output voltage. Suppose you have a switch here and here you have a resistance. Suppose you have this circuit where input voltage is 100 volt. This is constant DC source, as we have constant DC source as input voltage in case of DC-DC converter, and you have a switch here. The switching operation is given as, this is the switching operation. It means for this much time switch is on, it is connected, and for rest of the time it is off. Whenever I show a height, this will be on, there is no height, it is off. Here you have a resistance across which you are taking output, and this is very small resistance. So when the switch will be connected, there will be a current flow. Okay, the current will be 100 volt divided by R plus R, and V naught will be 100 divided by small r plus r into capital R. And if R is very small, the voltage will be approximately 100 volt. So when switch is connected, output voltage will be 100 volt. And when you will disconnect this switch, there will be no current through resistance, so the output voltage will be 0. Again, when switch is connected, you will get an output voltage. This is the output voltage waveform. To connect the switch, you will get the output voltage approximately equal to input voltage. You don't connect the switch, you will get 0 output voltage. Okay. So this type of output waveform you will get, and you can calculate average value of this output voltage. Input voltage is 100, and let's say this is 0.6 unit, this is 1 unit, this is 1.6 unit. So for this is 0.6 and this is 1, and after voltage waveform is repeated. So what will be the average output voltage? The total area divided by total duration. The total area will be 100 into 0.6 and the duration is 1. You will get 60 volt as an average output voltage, but the actual waveform of actual output voltages vary. Sometimes it is 100 volt and for rest of the time is 0. So this can be also thought of as a buck converter. The average output voltage is 60 volt, okay, and input voltage is 100 volt, so output is less than input voltage. So this works as a buck converter, but the problem is output voltage is variable. Practically what we need approximately constant output voltage. Practically in each converter, whether it is AC or DC converter, we need a constant output voltage. If it is giving average of 60 volt, so we expect that it is 100, we need this type of voltage, approximately constant voltage. Okay, so to make it constant or the voltage waveform is smooth, this is not a smooth waveform, this is highly varying. Let us connect a capacitor here. Now let us analyze what will be the output voltage. This is waveform of output voltage when no capacitor is connected. Now we will draw graph for output voltage with capacitor. Now when the switch will be connected, what will happen? The output voltage will be 100 volt. Okay, you are taking output voltage across resistance and capacitor is connected in parallel with the resistance, so the output voltage is equal to capacitor voltage. Okay, so in this duration capacitor voltage will be, this will also become 100 volt because this resistance is very less. Let us assume for a while there is no resistance, although two voltage step element cannot be connected in parallel. If these are connected in parallel, switching operation cannot be done. But let's say for a while this resistance is small and connecting as short circuited. So when this switch will be connected, capacitor will be immediately charged to 100 volt. Now when this switch will be connected, what will happen? Now what will be the output voltage? Output voltage is always equal to capacitor voltage. Now in this case what will happen? This switch is connected. Now capacitor will start supplying current to the resistance, and capacitor voltage will now decrease gradually. If just before disconnecting this switch, if capacitor voltage was 100 volt. Now when you have removed this switch, after removing this switch, the graph of capacitor voltage will be, or equation will be 100 into e to power minus t divided by tau, where tau is the time constant of the circuit. Okay, so here the graph of capacitor voltage will be, or the output voltage will be, if you will draw the graph of this circuit, we have already studied in network in the first order circuit that the graph will be like this. If you will increase the time constant, what will be the graph? The decrease in capacitor voltage or decay in the capacitor voltage will be slow. The transient will decay slowly. If you further increase the value of resistance or capacitance, the decrease in the capacitor voltage will be, this will be even slower. Okay, so in this duration, how much capacitor voltage will decrease, that depends upon the time constant. Okay, now what will happen at this point? The switch is now again connected. If this switch is connected, these two are in parallel. This is 100 volt, so this will immediately be on 100 volt. So the output voltage will be 100 volt again. Now it will remain at 100 volt. Although what I said, two voltage step elements cannot be connected in parallel. Okay, and switching operation cannot be done this way, but here I have to taken this example just to illustrate the role of capacitor. Now what is capacitor is doing here? Then again you will, when you will disconnect it, you will get the output voltage as this. So what is the overall graph of output voltage? You take one of these 3 or 4 voltages, the graph of output voltage is like this. Okay, now if you compare output voltage from the previous case, the variation in the output voltage is very less, and this is desired. If you want even a less variation, you will increase the value of capacitance, time constant will increase, so the variation will be, decrease in capacitor will be even slower. You will get this type of graph. So what is capacitor doing here? Capacitor is making output voltage smooth. It is making, if you connect a large capacitor, the output waveform will be very smooth. It will be essentially constant. Okay. What will be the effect of time constant? Why by increasing time constant the rate of decrease will be slow, or why I have drawn this type of curve, I have explained in the lecture of network in the first order RC circuit. You can refer that lecture if you did not understand here. Furthermore, you can also see with the help of this relation, capacitor current is equal to C dVc by dt. So what is rate of change of capacitor voltage? This will be IC by C. Now if you will increase capacitance, the rate of change of capacitor voltage will be less. Okay. For a given value of capacitor current, if you are increasing the value of capacitance, the rate of change of capacitor voltage will be, this will be lowered. So if you will connect a large capacitor here, the rate of change of capacitor voltage will be less, and since you are giving very less duration to decrease this voltage, for very less duration the switching frequency is high. If switching frequency is high, the switching duration of switching cycle is 1 upon f. If switching frequency is high, this duration will be less. If this quantity is less, T off will be less, and if T off is small, it means you are giving very small value for the discharge of capacitor, and by using large capacitor, the rate of discharge of capacitor is also low. So the overall decrease in capacitor voltage will be negligible, and capacitor voltage is equal to output voltage, so decrease in output voltage will be less. So from this discussion I just wanted to convey that the role of this capacitor here is to make output voltage approximately constant, approximately constant. Okay, and on this assumption only I will derive. Now we'll using this assumption only we will study DC-DC converter, and on this assumption only questions are asked in gate examination, and practically in every circuit output voltage is made constant. The constant output voltage is desired. Instead of connecting IGBT, I will just connect a switch and I will say this is a controlled switch. Okay, I have connected a capacitor here, so now I can assume output voltage as constant. If capacitor is not connected, you cannot assume this voltage as constant, but in each question that comes in gate, capacitor is connected. Okay, here we have a switch with switching frequency F. This is inductor. Now we will formally derive input output relationship between this buck converter. The switch it has a switching frequency F and duty cycle D. We have already understood meaning of duty cycle. D is nothing but T on divided by total time, and T is equal to 1 upon F. Okay, now to derive the relationship between input and output voltage, I'm going to give you one more concept. That concept is called, this is basically called flux balance, and this concept is also very useful in studying DC-DC converter or AC to DC converter. Okay. Although we have already discussed flux balance in studying AC to DC converter, but I will repeat it, flux balance, here also, because if you have not seen the lecture of AC to DC converter, and before introducing this, if I will apply to DC converter, you will feel difficulty in understanding it. So let me first repeat what is flux balance. Flux balance is that if inductor current is periodic, if IL is periodic, it means the average inductor voltage, the average value of inductor voltage, obviously average will be calculated on one duration, one time period. The average inductor voltage will be 0. So this is called flux balance. Okay, what happens in this circuit? The switching operation of this switch is periodic, means in one cycle you are connecting this switch for some time and then you are turning it off, and the same thing is repeated for the next cycle. If you are doing a repeated operation here, okay, you are repeating them, means if the switching sequence is periodic, everything in this circuit will be periodic. It means this diode voltage will be periodic, this current IL, VL will be periodic, VC, V0 will be periodic. Everything in the circuit will be periodic. Like when you connect an AC source, if this is periodic, resistance voltage, resistance current, inductor voltage, inductor current, all these quantity becomes periodic with the same frequency as the frequency of this AC source. Okay, so the switching sequence is periodic here. So inductor current will be periodic, and if inductor current IL is periodic, then flux balance says the average voltage across inductor will be 0. Okay, so now first I will prove it, and by using this concept we will derive expression for output voltage in case of buck converter. You would have already knowing that V naught will be the duty cycle into V input, so we will derive this relation. What is the formula for inductor voltage? Inductor voltage is L into dIL by dt. Okay. Now if you want to find out average value of inductor current, what you will do? Obviously inductor voltage, inductor current, each quantity will be periodic with the duration of switching cycle. If the duration of switching cycle is T here, so every quantity will be periodic with T. So voltage is also periodic with T, and you are interested in finding out the average value of inductor voltage. So what is the average value of inductor voltage? This is nothing but 1 upon T, 0 to T, VL dt. This is 1 upon T, 0 to T. The value of VL is L dIL over dt. L dIL over dt into dt. Dt and dt will be cancelled. The average value of inductor current is 1 upon T, okay, into L, and what will be the integration of TIL? You will get IL, and when you will put the limit, okay, let me first write it as limit 0 to T. So average value of inductor voltage will be 1 upon T into L, value of inductor current at T minus value of inductor current at T equal to 0. Now since inductor current is periodic with time T, okay, it means if it is periodic with T, suppose you have 0 here, then what will be the value of, if at 0 let's say inductor current is here, it has to be periodic with T, so after T duration it has to repeat its value. Let's say this is inductor current, so if it is periodic with T, after T duration it has to repeat each of its value. So the value of inductor current at T and value of inductor current at T equal to 0 will be same. Okay. You will get average inductor voltage as 0. You can also observe this way, since inductor current is periodic, okay, inductor current, change in inductor current will be integration of VL dt 1 upon L. From this expression you can write change in inductor current is 1 upon L VL dt. Since inductor current is periodic, so overall in one time period the change in inductor current will be 0 if it is periodic. So overall if you don't have any change in inductor current, so average voltage across inductor will be 0. So this is flux balance. Similarly we have a rule charge balance. Okay, charge balance is if you have inductor current, then you will use capacitor voltage. If Vc is periodic, then average capacitor current is equal to 0. If capacitor voltage is periodic, then average capacitor current has to be 0, and you can derive it in similar way. I will derive sometimes later. Because we have to derive relationship between input and output. Okay. Now we are coming to derivation only. Now let us draw. First draw the switching operation. Let's say for t on time, this switch is connected, and for rest of the time the switch is opened, and this is total time. Now the sequence is repeated, and let us draw here the inductor voltage. Okay, when the switch is connected, now we have to draw inductor voltage. So first we will have to choose inductor voltage reference, and this is inductor current reference. Okay. This is output voltage reference. Now when this switch is connected, what will be inductor voltage? If you move in this loop, here you have gain of input voltage, here you have drop of inductor voltage, and here you have drop of output voltage. So VL is nothing but input voltage minus output voltage. And since input voltage is constant and output voltage is made constant by connecting a capacitor here, so VL will be constant. Okay, so in the graph we will draw a constant line, and magnitude of that constant line will be V input minus V output. Let's say this height is V input minus V output. So as long as this switch is connected here, the switch is on, you will get inductor voltage as input minus output. When this switch is off, the inductor current will now take this path, because it has some value of current, and this current cannot be made zero suddenly, so this current will find some path. If a single path is available, this current will flow that path only. This current it has to come from, this is opened, so this current cannot flow from here, it has to flow through this diode. So now this diode is conducting. Now that this diode is conducting, this will be short. Now if it is short, now what is the inductor voltage? If you move in this loop, here you have drop of inductor voltage, and here also you have drop of output voltage. So VL equal to minus V naught. Okay, so when this switch is off, the inductor voltage will be minus V naught. One switching cycle is completed. Okay, when again you will connect this switch, the inductor voltage will be V input minus V output, and then it will repeat itself. Inductor voltage is periodic, inductor current will also be periodic, since the switching sequence is periodic. Now we will apply flux balance. The average inductor voltage has to be 0. So how will we find average inductor voltage? The average of any value is positive area minus this negative area divided by total time. Okay, this is 0, this is T on, okay, and this duration is, this is complete T, this duration is T off. Okay, so what is this area? height is V input minus V naught into T on minus, here it is giving negative area, this height is V naught minus V naught into this duration is T off, this will be 0. Why this is 0? Let us not write it 0. This is total area divided by the total duration T. This will give you the average inductor voltage, and it has to be 0 from flux balance. So you will write it as V input minus V naught into T on. This will be equal to V output into T off. V input minus V naught, T on will be written as D into T is equal to V naught, T off will be D dash into T. T and T will be cancelled. V input minus V input into T minus V output into T. This is V output. T dash is 1 minus T. If you will take this side, minus T will be cancelled and you will get V output equal to D into V input. Okay, so how did I derive it? I first, by connecting this capacitor, I said that the output voltage can be assumed to be constant. Okay, then I proved flux balance, and using flux balance we got this relationship. Okay, if you will not connect a capacitor here, V naught cannot be assumed to be constant. If this is not constant, you will not have a definite graph of, you cannot formulate graph of inductor voltage, and if you cannot formulate it, applying flux balance will be very difficult. Means in that case analysis will be very difficult, and that is not asked in gate. By connecting capacitor only, question will be asked in gate or any good examination. Let us, this is switching sequence. When switch is on, inductor voltage is V input minus V output, and this height is V input minus V output, and when switch is off, the voltage is minus V naught. Width is fixed, so I will take magnitude of V naught such that the positive area becomes negative area. Then only in that case the inductor voltage, the average inductor voltage will be 0. So I will take height such that positive area and negative area becomes equal. I have to increase little more. Okay. And this height is minus V naught. And inductor voltage will be periodic. Now we will try to draw graph of inductor current. So for drawing graph of inductor current, first I will talk about the average inductor current. First we will talk about average inductor current. If this output voltage is constant, here the output current will be I naught divided by V naught by R. I naught is, the output current is V naught by R, and V naught is equal to D into V input, means V naught is known, resistance will be given, so I naught will be known. Now to find out average inductor current, okay, why I am talking about average inductor current? Because inductor current will not be constant. dIL by dt is equal to VL by L. L di by dt equal to VL. So rate of change of inductor current is, this depends upon the inductor voltage, and here you have positive inductor voltage. So in this duration inductor current will increase, and when inductor voltage is negative, the rate of change of inductor voltage will be negative, means inductor current will decrease. So one thing is fixed, one thing is ensured, that in this duration inductor current will increase, and in this duration inductor current will decrease. And since this is one complete cycle, so at the end of cycle the magnitude of inductor current will be equal to magnitude of inductor current at the beginning. Okay, so to draw exact graph, let us first find out the average value of inductor current. This is inductor current. Let's say this is capacitor voltage, which is equal to output voltage, and as I have said in earlier lectures also, the reference of current will be taken from positive to negative of reference voltage. Here also the direction of reference current is from positive to negative of reference voltage. Then only you can use this relation, otherwise you will have to add a negative sign. Okay, so if this is inductor current IC and this is I naught, IL will be written as IC plus I naught. Okay, this relation will always hold from the circuit diagram. Now if you are interested in average inductor current will be average capacitor current plus average output current, and since output current is constant, so average output current will be V0 by R. So this quantity is known. What will be average capacitor current? Here again we need charge balance, the concept of charge balance. Charge balance says if capacitor voltage is periodic, the average capacitor current will be 0. Okay. How can we derive it? Capacitor current is equal to C dVc by dt. Let's say capacitor voltage is periodic with T, the switching duration of switching cycle. Capacitor current will also be periodic with T. Now average value of capacitor current will be 1 by T integration, either you write 0 to T, or let us write 0 to T only. Average capacitor current will be 1 by T 0 to T capacitor current dt, and capacitor current is C dVc by dt into dt. So this will be 1 upon T 0 to T, C can be taken outside, this will be dVc. This will give you C by T into capacitor voltage at T minus capacitor voltage at T equal to 0. And since capacitor voltage is periodic with T, so value of capacitor voltage at time T will be equal to value of capacitor voltage at T equal to 0. These are equal, so average capacitor current is 0 if capacitor voltage is periodic. So this quantity is 0, so we will say in case of buck converter, the average inductor current is equal to the average output current, and average output current is equal to V0 by R. So if duty cycle is given, you will calculate output voltage, resistance is given, then you can calculate the output current, and average inductor current will be, although inductor current is, I'm not saying inductor current is constant, but from this concept I have calculated the average value of inductor current. This will be V0 by R. So let's say this is average value of inductor current. This is average value of inductor current. Now in this duration, when the switch is connected, T on, in this duration the voltage across inductor, this is graph of PL, the voltage across inductor is positive, so di by dt will be positive, and this is V input minus V0 divided by L. This is the slope of inductor current, and the slope is constant. So if the slope is constant, the graph of inductor current will be a straight line which will increase, because slope is constant and positive. So you will have a straight line, okay, and from where this will start, in this duration it will increase, and from at this point it will start increasing. So obviously you have to draw a straight line such that its average value will give you the average inductor current. This will be the graph of inductor current when it is increasing. And in this duration, inductor voltage is negative. If inductor voltage is negative, dIL by dt will be, this is minus V0 by L. V0 is constant, so again you will have a straight line but with negative slope. This way inductor current will repeat itself. This is the maximum value of inductor current, and this is minimum value. When any quantity is varying, it varies as a straight line, the average value is the average value will be the mean of minimum and maximum point. Average will be minimum plus maximum divided by 2 if the variation is along a straight line. If it is making curve, then you cannot apply this formula. So since inductor current is constant here, and all these analyses are based when you assume V0 as constant. Okay, if V0 is not constant, if this quantity is not constant, okay, the slope will be variable, and if slope is variable, you cannot make it as a straight line. So since inductor current is, graph of inductor current is a straight line, the IL average will be maximum value of inductor current plus minimum value of inductor current divided by 2. And variation from average value, let me make this line solid, the average value of inductor current. The variation from the average value will be called ripple, the maximum variation. So ripple will be I max minus IL average, or this will be same as the average value minus minimum, average value minus minimum value of inductor current. So how will you find this height? This height is nothing but slope into this width. And what is this width? The total time is t on. Graph is a straight line. Okay, so this width will be t on by 2. Okay, so ripple will be the width, which is t on by 2, into slope of this line. So what is slope here? In this region, inductor voltage is V in minus V naught. So dIL by dt is V in minus V naught. So the slope will be V in minus V naught divided by L. Now you have to find height. Height will be this width into slope. The ripple will be the slope into width t on by 2. This is ripple. You can also find out from this triangle. Here height will be this slope. Okay, height is a magnitude. So here you will take magnitude of slope into magnitude of this width. So this width is nothing but this total duration is t off. So this width will be t off by 2. Okay, this width is t off by 2, and slope is in this region. The slope will be, magnitude of slope will be v naught divided by L. So ripple will be v naught divided by L into t off by 2. Ripple is, to ripple I will represent as delta IL. Delta IL is v naught into t off divided by 2L. So now you have ripple and you have average value of inductor current. So you can find out the maximum value. Maximum value will be average inductor current plus ripple. And average inductor current is nothing but the average output current we have already derived. So this way you can find out the maximum and the minimum value of inductor current. If you want to find out ripple, this is important to know. So if you want to find out in terms of duty cycle, or in the most simplified form, V input minus V naught will be D into V input divided by L, and T on is D into T divided by 2. So this will be V input divided by 2L into D into 1 minus D. Into T is also there. This will be V input divided by 2L, D into 1 minus D, and T can be written as 1 by F. So this will be 2 F into L. From here also you will get the same expression. You will write V naught as D into V input, T off will be D dash into T off is T minus T on, T minus T on is dt. This is 1 minus D into T. T off is D into 1 minus D into T divided by 2L. And to this T you can write 1 upon F, the switching frequency. Okay, so you got the same expression. We have ripple equal to, there are two quantities. One is ripple, the variation of minimum or maximum from average, and another quantity is peak to peak ripple. Peak to peak ripple will be maximum current minus minimum current. So peak to peak ripple will be double of this ripple. Here I am calculating ripple. Ripple is what? V input divided by 2FL into D into 1 minus D. In the converter circuit, we want this ripple to be minimum. Okay. So if you will increase, if everything is constant, if you are increasing switching frequency, okay, what will happen? Ripple will decrease. If you will increase inductance, in this case also ripple will decrease. Is it possible that for decreasing ripple, if you are increasing frequency, will there be any effect on output voltage? If you change the switching frequency, or if you change the inductor value of inductance, will there be any effect on output voltage? Expression of output voltage is, this is nothing but duty cycle into input. Output voltage depends only on duty cycle and input voltage. Okay, it does not depend upon the switching frequency and also the value of inductance. Okay, so if you will increase switching frequency or if you will increase inductance, ripple will decrease and your output voltage will be same. Okay, what is the duty cycle for which ripple will be maximum? Let's say you are varying duty cycle. Obviously output voltage will vary, but since ripple is important quantity, why ripple is important quantity? Because the formula we have derived in all the analysis, we have assumed that continuous conduction, or in any practical circuit, the conduction is always continuous. I have already talked much about continuous and discontinuous conduction in phase controlled rectifier. In short, continuous conduction is that when the value of inductor current is never equal to 0. At least for this circuit, if inductor current goes to 0, then we will say we have discontinuous conduction here. Okay, so to make continuous conduction, okay, inductor current must be greater than 0. Okay, inductor current should always be greater than 0. Okay, so if you don't want this inductor current to go to 0, if you make minimum of this inductor current greater than 0, you will ensure that inductor current is always greater than 0. If the minimum of inductor current is greater than 0, so rest all the values of inductor current will be greater than 0. So what do you want? IL minimum must be greater than 0. And what is IL minimum? IL average minus delta IL must be greater than 0. Now, if ripple in the inductor current is high, it is possible that IL minus delta IL, this may be less than 0 if you are increasing delta IL. Okay. So if ripple increases, there is a chance of discontinuous conduction. Okay, that's why we are giving so much time to ripple. So if you are interested to find out the value of duty cycle for which ripple will be maximum, what you will do, you will find out d delta IL by dt, the variation of ripple with duty cycle, and you will equate it with 0, and you will do this, you will get d as 1 by 2. In buck converter, when duty cycle is 0.5, ripple will be maximum, and that maximum value of ripple will be, if you put d equal to 0.5, delta IL will be 0.5, this is also 0.5, 1 by 4, 1 by 8, V input divided by 8 FL. I said that average inductor current minus delta IL, this is minimum value of inductor current, and this must be greater than 0. Okay, average value of IL is nothing but average output current, so this is V0 divided by R, minus delta IL is V input divided by 2FL into D into 1 minus D. This must be greater than 0. So to hold this inequality, if you are changing frequency, this quantity will be constant. If you are changing inductance, this quantity will be constant. Okay, so if you so for particular value of V0 by R, the value of switching frequency and the inductance can be adjusted to hold this inequality. It is better to keep switching frequency high, or it is better to use high value of inductance. Okay, you have the value of ripple, you have the value of average inductor current, so you can calculate maximum inductor current, minimum inductor current. We calculated the average value of inductor current. Okay, average value of capacitor is 0, average value of capacitor current is 0. Okay, so next we will, in the next lecture we will study a step up chopper, and we will follow exactly the same steps that we did in case of a step down chopper. In fact, if you have understood it very well, okay, you can do the same analysis yourself for a step up chopper, and if you cannot do, I will do that in the next lecture. And similarly we will do for buck boost converter also. One thing is remaining, the average input current. Okay, so to this also we will do in next lecture. This is very easy. Let us do here only. The input power must be equal to output power plus losses. If you assume that switches are ideal, if you neglect the loss, input power has to be equal to output power. Output power is V0 into I0, and input power is input voltage, which is constant, into average value of input current. Okay. So average value of input current will be just like transformer, we can do here. V0 is D into V input into I0 divided by V input. This is D into I0. I'm giving you one question for you to do yourself. Find out the value of average diode current.